thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Sydney Yeh.
And I'm Hannah Chu.
And we're your hosts for episode 12 called Chemistry of Cosmetics. Today we will be discussing the chemistry of cosmetics.
So, what are cosmetics?
There are thousands of different cosmetic products on the market, all with different combinations of ingredients. In the US alone, there are approximately 12,500 unique chemical ingredients approved for use in personal care products. A typical product could contain anything from 15 to 50 ingredients. Considering the average woman uses between 9 and 15 personal care products per day, researchers have estimated that when combined with the addition of perfumes, women place around 515 individual chemicals on their skin each day through cosmetic use.
So let's take it back to cosmetics in the olden times. Cosmetics were first seen in ancient Egypt, where makeup served as a marker of wealth believed to appeal to the gods. The elaborate eyeliner characteristic of Egyptian art appeared on both men and women as early as 4000 BCE. Kohl, rouge, white powders to lighten skin tone, and also malachite eyeshadow, which is like the green color that represented the gods Horus and Re. They were all in popular use as well. And then by 3000 BC, men and women in China had begun to stain their fingernails with colors according to their social class, which is kind of scary, while Greek women used poisonous lead carbonate to achieve a pale-like complexion.
Oh, that sounds scary. Let's get into the chemistry behind the cosmetics. A huge range of substances are used to create many appealing colors found in makeup. Mineral ingredients include iron oxide, mica flakes, manganese, chromium oxide, and coal tar. Natural colors can come from plants such as beet powder. Cosmetic pigments are broken up into two types. There are organic and inorganic. And an organic pigment consists of iron oxides, chromium dioxides, ultramarines, manganese violet, white pigments, and pearlescent effects. These are used for their opaque color coverage, making them particularly suitable in face and eye makeup. They're usually duller in appearance than organic pigments. The transition metals and inorganic pigments form colorful ions, complexes, and compounds. This is due to the unfilled d orbitals these elements have. When transition metals ions form complexes and compounds with other molecules, they become colored. They bond to one or more neutral or negatively charged nonmetals, also known as ligens, changing the shape of d orbitals. Unabsorbed wavelengths of light pass through the complex, and some light is also reflected back from a molecule. The combination of absorption, reflection, and transmission results in apparent colors of complex. The shimmering effects from makeup can be created by coating mica with titanium oxide and iron oxides to vary the refractive index observed in the finished product. Cosmetic mica typically comes from muscovite, also known as white mica. It naturally forms in flaky sheets, which are crushed into fine powders. The tiny particles in powders refract light, which creates the shimmering effect common in many cosmetics. Various thicknesses of titanium dioxide are used to vary the color effects that are created through the different refractive angles that are created. These refractive angles can be manipulated to visual effects of the finished products. Additionally, iron oxides combined with titanium dioxide coating can create a two-tone or luster effect. A variety of metallic and bright colors can be created using the pearlescent coating effect.
Emulsions are also common in the chemistry of cosmetics. Emulsion can be defined simply as two immiscible fluids where one liquid is dispersed as fine droplets into the other. Typically, creating a lotion or cream takes 3 phases: a water phase, an oil phase, and then a finishing phase that occurs after your emulsion has cooled. But, as we know, oil and water don't mix. This is because water is a polar molecule, which means that its structure has a positive charge on one end and a negative charge on the other end. Water molecules stick together because the positive end of one water molecule is attracted to the negative end of another. However, the structure of an oil molecule is nonpolar. This means that its charge is evenly balanced rather than having one positive and one negative end. This means oil molecules are more attracted to other oil molecules than water molecules, and water molecules are more attracted to each other than oil molecules, so they never mix. So since water and oil don't mix but stay separated, an additional agent, which is the emulsifier, is necessary to form a homogeneous mixture, keeping water and oil together. Without the emulsifier, you can mix the water and oil together, but then as soon as you stop, they'll fall out and separate back into oil floating on top of the water. So in cosmetic chemistry, we use emulsions to blend two immiscible or unblendable liquids together. An emulsifier stabilizes an emulsion by increasing its kinetic stability. Emulsifiers work because their molecules have two parts. One part is attracted to the water, and then one part is attracted to the oil. There are two types of emulsions. There's the oil and water emulsion and the water and oil emulsion. So an oil and water emulsion is composed of an oil phase that is dispersed in an aqueous one. It's known as a direct emulsion. Stabilization of the oil and water emulsion is often performed with hydrophilic and hydrophobic particles. The hydrophilic end of the emulsifier molecule has an affinity for water, and the hydrophobic end is drawn to the fat or oil. By vigorously mixing the emulsifier with the water and oil, it creates a stable emulsion. On the other hand, the water and oil emulsion is composed of an aqueous phase that is dispersed into the oil phase.
You might be wondering why we thought this topic of chemistry of cosmetics was interesting to us. This is because we are one of those many women that wear makeup and use these cosmetics that include all these many chemicals, as we have many chemical ingredients on our bodies right now. I have about 273 chemicals on my body right now.
And I have around 219 chemicals on my body.
So it's important for us to be cautious about what ingredients we put on our bodies, along with the types of chemicals and how they could affect us. In addition, it is important to know how some of these products we put on our faces are made.
I hope you learned something about the chemistry in cosmetics, so then the next time you put on some makeup, you know what chemicals are going on your body. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you go and visit www.hvspn.com.